Welcome to Pre-AP Pre-Calculus. We got a good lesson for you today. We're going to be learning about the law of cosines. Now, the law of cosines isn't as weird as the law of sines because there's no ambiguous case, or actually we just need to avoid that situation, but we'll get into that as we start doing some problems. So first off, here is the law of cosines right here. Okay, so it says if you have a triangle ABC with sides A, B, and C, and then you have these formulas right here. Now these formulas should kind of sort of look familiar. Okay? This is actually like the Pythagorean theorem, but with a little bit extra stuff here because it doesn't deal with the right triangles. Okay, so I'll just label this anything random. Let's start with A. I'll do A over here. Let's do B. Let's just put B over here. Again, the little b is across from the big B. And then I'll put C right there. Okay, so it works. Any one of these formulas work. Usually this is the one I just notate with all the time because, again, we can change anything we want. Okay, so it just whatever is across from the angle you're doing, that's what you're squaring, equals the leg squared plus leg squared. Okay, so this first example right here, we have just sides. Okay, so it's side, side, side. So it's going to be much easier to use law of cosines. So we're going to find the measures of A, B, and C. So it doesn't really matter which one's which. I'm just labeling randomly again. Okay. And then, so this would be 8 right here because it's little a. This would be 19 right here. And this would be 14. Okay. And this is not to scale whatsoever. It's just some random triangle we just drew and whatever. So what we want to do is we want to find the largest angle first. Why? Well, it's because we want to avoid any ambiguous case. Or, this should be an or, law of sines issues. So issues can come in for a law of sines whenever we are dealing with an obtuse angle. So we need to make sure that we can find our obtuse angle first if there is one and there's no issues. The issues come in for law of sines is when we find an angle and it happens to be obtuse and we just don't know what to do with it because your calculator is always going to produce an acute angle. Okay. So let's go ahead and find our largest angle. So we're going to find our largest angle by looking at our largest side. So we're going to have to find angle B first. Okay? So to find angle B first, we're going to go ahead and use the formula. So we're going to use 19 squared equals, I'm just going to go right across the formula. So the side squared plus side squared. So it doesn't really matter which one's which. Minus 2 times each side. And then cosine of, well, I don't know, B. Okay. So what I'm going to do now is I'm going to do a little bit of solving here. So I'm going to get this angle by itself. Okay, so you can just even use your calculator. Alright, so you're going to get 19 squared. Get out my calculator. And again, for your calculator, make sure it's in degree mode. Okay? If it's not in degree mode, this is not going to work out very nicely for you. Alright, so we're going to go through now. It's in degree mode. We're going to do 19 squared, which is 361, equals 8 squared plus 14 squared, which is 260, minus 2 times 8 times 14. Sorry, I did not know that was not on there, but I have a feeling you could do this on your own if you had to. Okay? And then from there, just go ahead and subtract this over. Oh, so we're going to get 101 equals negative 240 cosine B. Divide that 240 over, so we're going to get 101 over, well, it's negative in front, 240 equals cosine B. And we're just going to do inverse cosine in our calculator here. So inverse cosine of 101 divided by 240. So there is my angle measure. Nope, I forgot the negative, so that was not my angle measure. There we go. That's better. Okay, so we're going to go ahead and get 114.887 degrees. Okay, it appears I did make a boo-boo here. I think this was supposed to be 224, so it's my fault. So 220, it should be 224. So everything was correct. I just did a typo from my calculator over here, so it should be a 224. So now when we solve this, it should be a 116. My fault. That will probably happen again. Angle B equals 116.801 degrees. Okay, so that's solved for angle B. Now to find the next angle, I usually just go in order. So I found angle B, so I'm good there. I'm going to find angle C because it's the next largest one. From here, I'm just going to use law of sines. Much easier that way. So I have the angle B, so I'm going to do sine of B over 19 equals sine of C over 14. Now for B, I'm actually going to plug in this number, the full version of it. Okay? So I have it stored right over here. Okay, so I'm going to do sine of this value right here. Okay, times 14 divided by 19. And then I'm going to do inverse sine of that to find my angle C, which is, if I went too fast on that, it's because that we already did this, so I just don't want to go over it again in depth for the law of sines. Okay, to find our last angle, you just take 180 minus that, and that'll give you their last one. You don't need to do anything confusing like that. So this is actually going to give me an answer of 22.075 degrees. So these are my answers right down here. And again, it's not that difficult as long as you actually write down the correct numbers from the calculator. Okay? So let's do an example where it's not side, side, side. So here's a triangle. I'd usually just draw the same triangle all the time. I don't really care. Just whatever. This is it. Not to scale. This is A. This is B. This is C. So angle A is 115 degrees. B is 15. And C is 10. So we need to find the angle measures and A. So I'm going to quickly find A, and then I can use that for law of sines for the rest of them. So using law of sines, cosines, because we have angle, side, angle. So we're going to use this angle to find that. So we're going to get A squared equals 15 squared plus 10 squared minus 2 times 15 times 10 cosine of A, which is 115 degrees. Alright, so you would type this in your calculator, this entire thing, and then you would square root it. So let's go ahead and do that. So you're going to get 15 squared plus 10 squared minus 2 times 15 times 10 times cosine of 115. And then we're going to square root that answer. And A is going to equal 21.255. Okay? So now from there we can use law of sines, because we know that sine of A, which is 115, over A, which is 21.255, because I'm going to be using that entire number, equals, I'm just going to pick my next largest one, so I'm going to do B. So I'm going to do sine of B all over 15. Okay? You do your law of sines, and you can figure out what angle B is. for a shortcut for right now, because we're not learning how to do law of sines. We should already know that. You should be getting 39.762 degrees. Okay, and then we have 115. We have this 39 something, so we're going to take 180 and subtract those two numbers, which is going to give me an angle C of 25.238 degrees. Okay, so those are just two different examples we do. I'll leave this up here for just a second so you can finish copying it down. If you do have any questions, feel free to comment on the video. I'm sure there's someone in class that could probably answer your question if you have it, so feel free to ask questions for these two examples, see if anybody can answer it. If not, you can leave a comment on the video or leave a question. Or just remember to write the question down, remind me, we can go over it next class. Okay? Alright, so we're going to start to get into some word problems. Okay? So pitcher's mound on women's softball field is 43 feet from home plate, and the distance between the bases is 60 feet. The pitcher's mound is not halfway between, so some people just think that's for a baseball problem. But so how far is the pitcher's mound from first base? So here's the picture. So here's the mound. Okay. Here is home plate. Alright, so from here to here is 43. And then here's first base over here somewhere. And that's going to be 60 feet. And then we have this last one, which you just don't know. Okay? So this is actually what we want to find is right here. That's it. So I need an angle, and the angle is actually going to come from right here. Alright, so just to give you a heads up on baseball fields, they make, if I were to draw all of the bases, it's probably not going to fit on here, but if I were to draw all the bases, it's a square. Okay, so this angle would be how much? Very good, 45 degrees. So now we can use our law of cosines to figure out this value right here. I'll just call this C. So my C squared is equal to my 43 squared plus 60 squared minus 2 times 43 times 60 times cosine of 45. Okay? Go ahead and try that out on your calculator. Alright, and then you should be getting answer of 42.43 feet. I don't know if there's another decimal in there. I'm just copying her off the notes for this one, so I don't know if there's another decimal there, but we usually round to the thousands. But for this one, the note just has this. Alright, area of a triangle. So we did one using law of sines, which is kind of easy to understand, especially compared to this one. So for area for a triangle, we can also use Heron's formula. Okay? So this is what it is. It's just the square root of s minus a, s minus b, s minus c, where s is a plus b plus c over 2. This is the semi-perimeter. Okay, so you find the semi-perimeter, and then you do that minus each side individually, square root of that, and this is when we have a side, side, side. Okay? So find the area of a triangle with these lengths right here. We got 43, 53, and 72. So we need to find the semi-perimeter. So we just do that by adding up all these sides and dividing by 2. When you do that, you get 84. so you just use your formula. So unfortunately this is a formula you're going to have to memorize. So it's going to be 84 times, just do this minus each side. 84 minus 43. 84 minus 53. 84 minus 72. Type that in your calculator. I'm sure you'll just have faith in me. 1131.886 meters squared. Okay. Alright, the ship leaves port at noon and heads west at 20 knots, which is 20 nautical miles per hour. At 2 p.m., the ship changes course at 54 degrees west. Find the ship's bearing and distance from the port of departure at 3 p.m. So we're going to have to go ahead and draw this. So I'm just going to start it right here. Okay, so we're going to go west here for starting at 2. Nope, sorry, it starts at noon and then at 2 it changes, so that's going to be 40. So we're just going straight here for 40. Okay. And then from there, we're going to change course at northwest. So northwest is here, and this is going to be 54. Pretty close to the middle. That's I'm going to go for 1 hour, so that is only 20. Okay. And here is the resultant from where we started to where we finished. So it wants to find the ship's bearing and distance from the port. So the distance one is the easier one to figure out. Okay, so we have 2 lengths to find this. We're going to need this angle value right here. Okay, so if this part, there's 2 parts to it. Just color it in. I'll do orange. Orange is the easier one. And let's do pink. Pink is the slightly tougher one. Okay, so orange, since it's the entire first quadrant, is going to be 90 degrees. And pink, which is said, is 54 degrees. Add those together and you get 144 degrees. So to find this length right here, I'll call that C. It's C squared equals 20 squared plus 40 squared minus 2 times 20 times 40 cosine of 144 degrees. And this is just all from the formula. Okay, so now what we're going to do here is find for C, and I'm just going to tell you that when we solve for it, it's 57.397 nm nautical miles. Okay? It also wants to find the bearing. Okay, it really should be, yeah, we'll stick with bearing. So this is going to be our compass bearing. Okay, so from the port of departure. So it's from here, because we started here. Okay, and to there. So I want this bearing right here. Okay, so it looks like it's going to be northwest. Can we agree that that's going to be northwest? Because we want this bearing from this where we started. So it's going to be northwest something. Okay, so we need to figure out this angle measure right here. We need to figure out red. Well, in order to figure out red, we probably should figure out green. Because do you agree that green plus red should give me 90 degrees, because it's the entire first quadrant. So how do I find green? Oh, very good. You're just going to go ahead and use the law of sines. Okay, because what's across from green? It's 20. So I'm going to call this A. So sine of A over 20, and let's find a relationship that we do know, which is going to be this 144 in C. So sine of 144 degrees all over this C value, which is this 57.397 and there's more values. So make sure you use that entire value. So when we solve for this, we're going to get A to equal 11.818. So that's just the green part. Okay, degrees. Again, I'm just not showing you the calculator work. We have done this before. So to find red, we're just going to do 90 minus this 11.818, which is 78.182 degrees. So now I have red. So the bearing we said is going to be northwest. So it's going to be north 78.182 degrees west. So this is my distance. And this is my bearing, which is from the starting point. Okay, so from here it just gets a little repetitive with problems. So I'll give you a chance to work on some of these. So right now on the video, can we please work on 6 and 7? And meanwhile, you're going to please pause the video so that you can work on this. When you're ready, hit play, and we can check our answers. Okay, so this is what I got. Very similar to the last question. The tricky part here is getting these two numbers, the 2's. Okay, so we're going 8 knots for 15 minutes, and this is per hour. So this is a fourth of an hour, so it's going to go over 2. Alright, and then this one is going 10 knots for 12 minutes, which is going to give us, again, 2. 12 is a fifth of an hour. So once we get those, we just set it up. Okay, and feel free to hit pause because I'm about to move on. Okay, if there's any questions, again, feel free to ask. Someone in the class might understand it, or save it for next time. Okay, so from here, these problems get a little repetitive as well. I'm just going to skip on to 8, and we're just going to finish up on number 8. Keep this video a little bit on the shorter side. So we have find the length of the sides of a parallelogram if its diagonals are 26 and 20 centimeters long and intersect at a 50-degree angle. So I'm going to just draw some random parallelogram. And we have diagonals. Okay, they always intersect at an acute and an obtuse, so it tells me what the acute is. The acute is going to be 50. The diagonals are 26. That means this piece right here is going to be, well, this is the longer side, by the way, because it travels longer. So this is going to be 13. This little part's 13. This little part's 10. That little part is also 10. Okay, so find the length of the sides. Okay, so since this is 50, this right here is going to be 130. All you're going to do is set up the law of cosines to find out this side right here. I'll call this A, and this side right here, I'll call this B. So to find A, it's going to be A squared equals 10 squared plus 13 squared minus 2 times 10 times 13 cosine of 50 degrees. Finding B is very similar. It's going to be 10 squared plus 13 squared minus 2 times 10 times 13, but this time cosine of 130 degrees. Okay? So if you, I'll give you a chance right now to use your calculator and solve it. Okay? So please hit pause, and when you're ready, hit play to continue. So for A, I'm going to get 10.093 centimeters, and for B, I'm going to get 20.883 centimeters. Okay. Alright, well that is all. And you're going to go ahead and get your worksheet started, and you should have plenty of time to work on that. Thank you for watching. Well, you kind of had to, and enjoy the rest of your day.